Welcome for the afternoon session. This is the IPC session for the 1 to 2 p.m. We have 5 presentations for today. For this particular session, each of them will have around 10 minutes presentation, and we can afford to have 1 or 2 questions at the end if we have time. And the first presenter is Weiqi. Her presentation topic is on allocation in life cycle assessment of recycled aggregate and CO2 concrete.
Try. Yeah. Hello, everyone. I'm Weiqi, and I'm from Western Sydney University. So, sorry. So the topic I would like to discuss today is the allocation in life cycle assessment of recycled aggregate and CO2 concrete. So Australia economy has been remarked as very strong growth in the future. And the construction and demolition waste will be more emphasized in line with the circular economy set by the Australia government. So typically, the Australia set a goal to improve the waste recovery rate to 80% by 2030, and such recycled material utilization are enhanced by the government and industry in the near future. So you can see here, construction and demolition waste is being more emphasized in the country, which the incremental amount has reached to 32% in the past 10 years. And in line with the circular economy strategies, a practical and economic solution in the construction industry is to use the recycled aggregate, which both improving the waste recovery rate and increase the recycled material utilization. And we found that substituting the virgin aggregate into the recycled aggregate is practical and ideal in the structure and other sustainability issues. So typically we can use the 100% recycled aggregate in the concrete. And however, we found that it's mostly used in the pavement application, but not for the structure use. However, in the Western Sydney University, we have a group to help develop the structure proposed recycled concrete, and we use some we inject a certain amount of CO2 into the recycled aggregate to produce CO2 concrete. So this one is the recycled concrete, but there are a lot of benefits in here. For example, in line with on the basis of the comparative mechanical strength to the virgin concrete, it can be beneficial to the carbon emission reduction and cost saving. Also, it promotes to the waste recycling rate because we use a lot of supplementary cementitious materials and also the recycled aggregate into it. And for this study, to consolidate the sustainability potential of CO2 concrete in a broad environment perspective, so a life cycle assessment study is critical for our study. And also, we concern the issue for the LCA method, which called the allocation issue for the use of the recycled aggregate. So what is allocation for the multifunctional process? And ISO standard has regulated the hierarchy of allocation method applied in LCA study. So we can summarize them as 3 steps. First is to subdividing the process or expanding the product system. The second is to use the partitioning rules, reflecting the physical relationship between the main and the co-products. And third is for the another allocation method, which can be called the economic value method. And in this study, we select the 4 typical allocation methods in here. The first one is the cutoff rule, which means we treat the C&D waste is pure waste and allocate no impacts from recycling. And second is the physical allocation. The third is the economic allocation, and the last one is half-to-half partitioning rules. So this figure shows the different scenario for the allocation and the allocation coefficient applied in the LCA study. So cut-off rule means allocation coefficient is 0, and half to half is the 50%. For the physical allocation and economic allocation, they are calculated based on the manufacturing process of the recycled aggregate in Australia and their general price. Also, LCA model for this study is developed by the typical manufacturing technology used in Australia and their transportation distance and mode. The functional unit is the 1 cubic meter of the concrete, considering the 28 days compressive strength and durability, and the system boundaries aggregate and CML methodology is used for the LCIA. So 4 types of the mixed design I select. Typically, the mixed design are identical and and they have the comparative compressive strength. But the main difference is that the aggregate content and the type are changed. So this figure shows you the life cycle impact assessment results for the virgin concrete and CO2 concrete. So from this one, we use the virgin concrete as the reference, and the cutoff rule is applied to recycled aggregate. And from this, we will find that some CO2 concrete performs better than virgin concrete. And specifically, you can find that for the abiotic depletion and the corresponding fossil fuel consumptions and the ozone depletions are much better. However, they have the quite similar performance regarding the global warming potential and photochemical POCP. So we should highlight that although they have some indicators which has the quite similar performance, it's because we use the additional CO2 injection. And when we consider the allocation rules, we will find the benefits from CO2 concrete is much better, especially for the economic allocation rules. So you will find that for the ODP, which performs best, and for this type of material we used for the CO2 injection, we also consider the economic allocation rules for the CO2 injection, and there are also some indirect benefits from the recycled concrete use. For example, when we use recycled concrete, the waste recycling rate will be promoted, as well as that once CND waste is recycled, byproducts such as the recycled steel can also be recycled and benefit to the environment. And from the results we discussed before, we will find a higher virgin aggregate replacement ratio benefits to the overall environmental impacts. And a location rule in combination of the virgin aggregate replacement strongly influence some environmental impact indicators of CO2 concrete. And in the Australia context, economic allocation of recycled aggregate recycling is more preferred, because if you can find some relevant articles, you will find they discuss that the allocation rules is not very effective to the impacts of recycled aggregate, but it's not the case for the Australia. That is because we had a very heavy landfill levy for the CND waste. So that's why we recommend to you to use the economic allocation rules for the recycled aggregate. And the extended transportation distance of virgin aggregate makes CO2 concrete more attractive, since there are lot of phenomena recently that the quarries has been extracted for the rural areas, and the transportation distance will be much higher than before. Okay, that's all for my presentation. Thank you.
Thank you. We can have one question. Please stay, Gigi. Any questions from the floor? If no, thank you very much, Gigi. Our next presenter is Mingxue Ma. Mingxue is presenting a topic which is also related to CO2 concrete, but on the price perspective. Her topic is on impacts of policies on the price of recycled concrete. Probably to give a couple of minutes.
Okay. Hello, everyone. My name is Mingxue Ma, and I'm from Western Sydney University. And Professor Vivian Tam is my principal supervisor. And the title for my presentation is the impacts of policies on the price of recycled concrete. So during this presentation, I will firstly briefly introduce the background of this research. Then I will talk about the research methods and research results. So the rapid urbanization and significant increase in construction activities has led to the production of massive construction and demolition waste. 80% of the construction and demolition waste could be reproduced into recycled aggregate, which could partly or entirely replace the virgin aggregate in concrete. So recycled aggregate is appropriate for the production of recycled concrete, but generally there is a loss in the physical and mechanical properties. The quality of recycled concrete is considered inferior to that of virgin concrete. Recycled concrete is usually not considered for the structural application. So recycled concrete is unable to produce favored financial outcomes to the industry because its price remains higher or equal to the price of virgin concrete because of some recycling treatments involved, which causes the reluctance in its utilization. And clients and consultants rather concentrate on the financial considerations than any other environmental benefits of the materials. So to increase the popularity of recycled concrete, it's of great importance for it to be less costly. The increasing popularity of recycled concrete requires a strong market. Some countries proposed a set of policies to reduce the hesitation of customers and nurture the market incentives to produce and use the products recycled from the C&D waste. However, the impact of these policies on the price of recycled concrete remains unknown. A great collection of previous literatures has been conducted to study the properties of recycled concrete. In order to compensate the inferior quality of recycled aggregate, past researchers presented several different ways to improve the quality of recycled concrete. And there are studies which assess its environmental impacts and financial performance. So far, the previous studies which carried investigations on the impacts of possible factors on the cost of recycled concrete is limited. Therefore, this paper will derive the list of policy factors which might affect the price of recycled concrete. And this paper will conduct the mean score analysis and the one-way ANOVA through SPSS to analyze the importance of each factor. And the findings of this paper could help policymakers to enhance the performance of C&D waste management. And in this research, China is selected. So a set policy factors are derived from the literature review. And we send a web link of the questionnaire survey to 150 potential respondents. And we have collected 97 useful responses. And this study will use the SPSS to calculate the importance of each factor. And therefore, through the literature review, 10 policy factors were identified. They are the mandatory use of products recycled from C&D waste, formulation of standards for recycled aggregate, landfill ban on recyclable components, strengthened supervision on landfilling and recycling, forbidden C&D waste export, on-site separation of different classes of C&D waste, subsidized for the use of materials recycled from C&D waste, tax deductions for the recycling activities, subsidized for recycling activities, fines for the startup of the new recycling business. And 3 policy factors were identified to have the most high scores. So they are the formulation of standards for recycled aggregate, strengthened supervision on landfilling and recycling, and tax deductions for recycling activities. So the first one, the formulation of standards has the highest score. So normally the insufficient, the demands and the supplies are major barriers hindering the market popularity of the products recycled from the C&D waste. The technical and the product standards play an important role to promote usage of the recycled concrete because they can enhance the user's confidence, increase acceptability level. And however, formulation of the technical standards is not a frequently used measure. Although some advanced cities, they have developed local technical standards, about 90% of Chinese cities have not developed local standards. And strengthened supervision on landfilling and recycling has the second highest score. Imposed supervision system could reinforce the obedience of the related stakeholders, trigger the efficient recycling chain. And as the C&D waste management is still at the initial stage, government supervision is identified as a key factor to efficiently manage the waste. An upgraded supervision system could trace the waste from its source to the final disposal site and verify the waste quantity to recycling. It could ensure the proper demolition work, recycling of recyclable components in C&D waste, prevention of the unlawful landfill, and the production of the high-quality products. Furthermore, because it can increase the recycling of C&D waste, supply of recycled concrete could be improved accordingly. Tax deductions for recycling activities has the third highest score. The government-supported policies normally a determining factor to promote the practice of C&D waste management because it's highly related to recyclers' economic viability. So tax deduction is one political strategy to establish the financial advantages for the recycling companies. Tax reductions could encourage the recycling activities, which could increase the supply of recycled concrete. It also might decrease the selling price of recycled concrete for less tax imposed. And then I used the one-way ANOVA. I classified the respondents to 3 categories. They are the academic people, the government officers, and the industry practitioners. The results imply that the perception on the importance of each factor were not affected by their occupations. This agreement is seen might be because the price of recycled concrete is closely associated with the adoption of a major recycling market, which is major concern and attract interesting increasing attentions in the recent years. The policies are necessary to establish the demand and supplies for recycling products within the industry. So that's all my presentation. Thank you so much.
Thanks very much. Looking into the price perspective, do you have any question? No? Okay, thanks very much, Mingxue. Our next presenter is an additional from the program, which is Lei Liu. He will be looking into the embodied energy review perspective.
Hello, everyone. My name is Lei Liu, and a PhD student from the Western Sydney University. As you can see from this slide, my research is titled "A Review on Modeling for Life Cycle Energy Estimation of Buildings." I will introduce it from 3 major parts. Firstly, to introduce background research question, aim, and objectives, and then design the theoretical basis, methodologies, and finally to discuss the results, future direction, and significance. To begin with, as you all know, with society and economy development rapidly, many energy issues that cause global warming and air pollution are increasingly at an alarming rate. Undeniably, it has become one of the most concerns worldwide. As shown in the figure 1, we can find the buildings accounted for the biggest proportion, over 35% of energy consumption. Taking China as an example, it has contributed to 24.3% of global energy consumption, and 46.5% of them is from buildings. So many governments have to take energy conservation in the construction industry as one of the most important and urgent issues to be solved. So to date, the related research and practice are fruitful, such as green buildings, passive design. But I find the energy consumption estimation got more attention in academia recently because it can plan future energy saving policies and adjust the current energy technologies and services. But however, also many advanced technologies and methods are applied, there still have been significant estimation errors for the energy consumption of buildings. So I hypothesize there are 2 main reasons. One is the life cycle energy boundary of buildings. In the past, most studies focused on the embodied operational energies, but now the mobile energy relating to building environment was found indirectly affecting the energy consumption. To be specific, the building location, indoor comfort, and surrounding environment will affect the daily commuting travel modes and occupants' behavior. So we needed to explore its impacts on life cycle energy system. And besides its the estimation methods, of course, there are a lot of various estimation approaches, but I guess they have different degrees of limitations. So based on the two research question, the aim of this research is to do a systematic review to explore and summarize the current estimation methods of life cycle energy consumption of buildings. There are three objectives: defining the life cycle energy boundary of buildings, and review the current research progress of three major energies, and finally to find and assess their main estimation methods. For the specific steps, firstly, I established the theoretical framework as showing the diagram. The life cycle energy of buildings consists of embodied, operational, and mobile energies. But in fact, the embodied and operational energies didn't change anymore, the same as the previous studies. We just redefined the mobile energy. It includes two parts, daily commuting and auxiliary facilities. And then we conduct the standard systematic review procedures to find out relevant researchers. It includes three steps: literature screening and quantitative analysis and qualitative discussion. According to the search condition I designed, which includes search terms, extension words, databases, screening criteria, we can filter out 109 articles from the 8,129 search results for reference. Next, we have to perform the text mining and sort of data to overview the current energy consumption estimation status. We can find the overall trend of life cycle energy estimation of buildings as expected. It has increased at a moderate rate. And on the other hand, the publication numbers of mobile energy related researches were relatively small, just accounted for 17%. And according to the keywords cluster statistics, we can find some high pressure, high frequency keywords, such as residential buildings, embodied energy, and modeling. And according to the author's citations statistics, we can find Dixit and his colleagues were regarded as one of the most influential researchers in this field. So we can refer to their studies later. And next, we needed to do the qualitative discussions and assess the estimation methods of three major methods. Firstly, as for the embodied energies, we conclude that there are three major methods. One is the process-based LCA. It divides into three parts: initial, recurrent, and demolished embodied categories. And another is the input-output-based LCA, which is based on the microeconomics. So they are from different perspectives. So the third is the hybrid LCA. It successfully combines the strengths of the two methods above mentioned. But it is not perfect. But it is also not perfect because it lacks specificities for the sake of its aggregation. And then it's operational energy. It includes five types of models: microeconomics, statistics, reduced order method, engineer, and machine learning. we can depend on our purpose to choose to select appropriate methods. So finally, it's the mobile energy. It consists of 4 models, basic models, infrastructure-based LCA, commuter model, and the travel model. I want to say one of the biggest difference of them is the parameters diversity, because the definition of mobile energy is the more accurate the selected parameters are. So we needed to analyze the mobile energy definition later. And according to the summarized above, we found all estimation methods have different degrees of limitations. So in the future, we needed to pay more attention on the 5 research gaps I found: mobile energy, quantitative, life cycle energy, integration, benchmark and guidelines, rebound effects, and policies impacts. Finally, I wanted to say its significance. Of course, it proposed a new theoretical framework for the life cycle energy of buildings, and it overviews the current main estimation methods of 3 major energies: embodied, operational, and mobile energies. Also, it provided the future research directions for researchers in this field. So I think it's a valuable reference. So that's all my research content. Thank you.
Thanks very much. With 12 months into his research, into his PhD already, with this presentation, I think is a pretty good progress. Any questions from the floor? Yes. Yeah.
Hi, thank you for your presentation. I wanted to ask about the results, how the results will change with the different LCA methods. Are the results the same or they are different by changing the LCA method?
Give me a sec.
Yeah, I just need to conclude the main estimation methods. So I didn't to deeply research the LCA. Maybe maybe just like the embodied energy, it includes process-based LCA. It depends on LCA and based on the LCA and to do more like this. Just to summarize the main estimation method, maybe. Okay, thank you.
Cool. Thanks. Thanks for your presentation. I was going to ask you what the aim of your PhD is. You alluded to that it might be to develop a framework for life cycle energy modeling. Is that right? Is that correct?
Yeah.
Yep. That includes mobility. Yeah. I noticed in one of your diagrams you didn't have, in terms of researchers that have worked in this area, have you come across Andre Stefan's work?
Yeah.
Yep. Okay. All right. It just didn't see it mentioned there, so that's all right. No worries.
Okay, thanks very much, Lei. He's sweating. Okay. There are 2 more presentations for this particular session. Unfortunately, the 2 graduate students are not here. That's why I'll be presenting the last 2 presentations in here. The first one is talking about on the life cycle impacts from environmentally friendly blocks, which is actually a case study from a New Rock construction, which is a consultancy project, which is by New Rock. I think you may heard of New Rock. New Rock actually is initiated from US. But he actually also have plans in Australia, mostly Sydney at the moment. What they're asking us to see is because their products actually using basically is almost new cement. I mean, no cement in there. and they're just producing the similar products compared to the virgin bricks, and they want to compare the performance of that. What are they really different is you can see that they want to see the eco-friendly bricks and blocks, that they're using the industrial waste. They have their trade secrets. I don't know what are the ingredients in the bricks, but they just use no cement, but they will use most of the ash. They'll use most of the ash, and they'll use their binders. Obviously, the binders are the main thing to substitute the cement component. And that's the reason that they want to see the comparison between the conventional product and the New Rocks product in terms of their life cycle environmental impacts analysis. What their product is, you can see this is their manufacturing process. From the inceptions, they are using, the difference is the pot ash. That means they are using the ash from the ash dam to manufacturing the bricks, and then they mostly using it for nilcreting, which is the same thing as what you will use for the concrete critting, but they call it as nilcreting. And the process is they will be producing a lot of their company products, and they will use it for the ultimate products. Basically, it's comparison for the virgin materials. What we're looking into a couple of methodologies for this particular project. First is the scope analysis. We want to ensure that it's looking into the life cycle perspective. That's why we're looking from inceptions, go to the raw material extractions, manufacturing, transportation, constructions, operation and maintenance, and the end use life cycle. And we're looking into the cradle to grave process in here. And we look into a couple of components, looking into the climate change perspective, and also the ocean dispersion, which is from the data extracted from the resources. First of all, you can see the raw data extraction materials is we have the consideration of the transportation distance is assuming as a 400 kilometers, and also the transportation vehicle with the assumption of the certain carbon dioxide emissions in here. And when you see the comparison in here under our environmental impact assessment, you can see that when we're using the greenhouse gas emission for truck and the diesels, these are the data. The diesel is way lower than what we are using it for truck. That's why the total emission for New Rock blocks is actually also lower compared to the virgin. What we calculate from the data is around 27 kilogram of carbon dioxide equivalent per tons that we are produced, and compared to the others, which is lower on that compared to the material. Another one is the climate change analysis, which is very similar perspective, because we're looking into the middle stage, which is the manufacturing stage, construction stage, and also the demolition stage. And these are the different weighted data regarding to their carbon dioxide equivalent emissions. And the same thing, which is for the ozone dispersion analysis, again, looking into the 3 different processes, manufacturing, construction, and demolition stage. And these are also the data emitted from here. And in general, what we can see is New Rock producing the environmental and social benefits because they are using the cleaner materials, they are producing the healthy issues, and they also could create jobs as well because it's a new perspective. That's why they create jobs. And compared to, as you know, construction industry produce majority of the cement, and the cement industry actually contribute majority of the carbon emission. And for this particular New Rock bricks and blocks, they actually using close to new cement, and that's why that perspective is also the major contributor for their productions. And from that, obviously, you can also bring it to the perspective because we're looking at the life cycle, not only about the carbon emission, we also have a cost reduction in here as well. And that's why we can actually highlight that this particular consultancy to gain the benefit of what New Rock's product compared to the conventional products. And that is just a quick summary of what we have mentioned. Probably a bit highlight in the data in here is the New Rock bricks is only using about 27 kilogram of carbon dioxide emission, but the conventional one is about 67 to 103, which is around a quarter of the carbon emission compared to the virgin materials. And in general, around 60% reduction as minimum that we can save from the New Rock products, which the company is really happy to promote their product in terms of the environmental perspective. That's the end of this presentation. Any questions? If not, I'll move to the next one.
Thanks, Vivian. Thank you. You don't get over that easily.
Yeah.
Just in relation to the second last point in terms of the emissions savings, I noticed you went through it very quickly, obviously.
Yeah.
I noticed the mention of Gabi for background LCA data.
Yep.
How much of that, so just generic process data was used versus specific data I'm imagining you were using the plant in Sydney for the
Yes.
specific data? So,
Yep.
so what was the balance between generic background process data and specific data you collected for the process?
To be honest, because of this particular product is under trade secrets, there's a lot of data that the company is not able to provide the details, but we have provided very logistic assumptions in there, and that's why they're also only mainly using the generic data for comparison, which is also good for the outcome as well. Yeah, but there's a lot of trade secrets there. There's a little bit difficult to manage.
Okay, so what processes, do you remember what process you used for the background data? Because obviously if it's a new product, they're not going to be captured in Gabby databases.
Mm-hmm.
So how
No.
relevant, how much error is there associated with that actual finding that you came up with?
We are still using the generic data, but we just assuming the quantity of the material that we have used. Say, for example, we compare to the cement components. Obviously, new rock is looking into the new one, and also different kind of mixed proportion as well. We do have a assumptions of the rough mixed proportion that we are using compared to the for the natural material and also new rock materials. But obviously, those are also the companies are happy with that assumption. I think is relatively aligned with what they are using as well, but may not be exactly the same. And that's why we're using it for comparison in here, but relatively assumption in there. Yeah. Okay. Thank you very much. Thank you. I'll move to the next one. The last presentation for this particular session is another one is on CO2 concrete. Gigi has talked a lot on the life cycle assessment. Mingxue was talking about the price of the recycled concrete, but this particular one want to look into the strength behavior. And I also want to talk a little bit of the background story of this particular product as well. For some reason that I'm putting this particular introduction of myself, since it's promoted in here, I will talk a little bit on that. My research interest, actually, you can see that these are all my students, which is all based on this particular perspective as well. The research interest is aligned with the sustainable construction, focusing on green building. You can also see the majority of them also working on the life cycle analysis and also focusing on the recycled concrete, as you can see. I'm currently the editor-in-chief of International Journal of Construction Management. I'm also the senior editor of the Construction and Building Materials, which with impact factor just over 6, which is the Q1 journal. There's also a little bit of information regarding to my research fundings. Currently, I'm holding 6 ARC projects and some of my research outcomes and research impacts in here. Which is another generic overview of what I'm working on. You can see that in the middle, as I mentioned, is the sustainable construction management and engineering. I started when I was an undergraduate student doing research on the environmental management and waste management. Where management perspective, because I'm actually a management background students, in the construction management background students. For some reason, when I moved to PhD, I actually moving to a bit of a technical perspective because of my supervisor got a recycled concrete project, and I'm willing to take on to try some new things, and that's why I just work on the recycled concrete technologies when I was a PhD student, which is a big shift, but it's also a big learning curve as well. Recently, I'm looking into a bit more on the green building, which is a little bit more on the modeling perspective, like the multiple input, multiple output systems. And all of those, you can see that we're looking on the life cycle assessment as well. What I want to talk about this one is we want to talk about the products of the CO2 concrete. We want to highlight that all of those are actually related to the problems. What are our problems? Our problems are two, is our huge construction waste. If our huge construction waste, because we are producing roughly about 22.9 million tons of masonry waste annually, and unfortunately, we only have less than 1% of them are actually reproduced in concrete. And we also have huge amount of carbon dioxide emission. As I mentioned, cement production are actually producing roughly about 5 to 7% of the world CO2 annually. That's why we always try to find ways to reduce the cement contents or to substitute the cement contents. And these issues need to be resolved. And what we are looking into, we have a solutions of developing of CO2 concrete. I think a little bit of background already, but I will just quickly mention about CO2 concrete is by injecting carbon dioxide into the recycled aggregate to produce the recycled concrete, and which is obviously to able to improve its bondings. And there are two main benefits from the CO2 concrete. First, because we are reusing the waste. That's why we are reducing the landfill space, which is supposed to go to landfill. And we are also injecting the carbon dioxide, which are the unwanted carbon emission in here. That's why we are using two waste products. Is the recycled aggregate, recycled concrete waste, concrete waste, and the carbon emission. what you can see in here is our carbonation chambers in the laboratory. In the middle one is our version 1, which is developed probably about 5 years ago, relatively on a laboratory scale. As you can see, it's about 50 centimeters by 50 centimeters by 30 centimeters, which is at the initial stage. At a later stage, we have a chance to provide a little bit more of a commercial scale. That's why we upgraded our carbonation chamber to 1.2 meter diameter and 1.6 meter high, which is about human height, and enough to put 1 ton of aggregate to carbonate for 1 meter cubes of concrete with 100% replacement. We have done any test that you can imagine, including workability, strength, and also durability performance. And you may ask me, how does it work? As you know, recycled aggregate is with the original virgin aggregate, but with also with the very poor old cement mortar attached. The virgin aggregates are not the thing that we worry because they are still strong, because they are dense. They wouldn't change in nature after 50 years. But the cement mortar is the one we cannot avoid when we crush the recycled aggregate without the attachment of the old cement mortar. What we are doing is we need to improve this old cement mortar attached by injecting carbon dioxide. Once they go inside there, they are able to strengthen it, obviously with a certain environment of the carbonation process. What you can see in here is the left-hand side is the virgin concrete performance. If we're replacing different proportion of the recycled aggregate, the strength actually go down. When we're replacing 100% of the recycled aggregate, there are actually 30% strength reduction. But if we, by injecting carbon dioxide into the recycled aggregate of 100%, we actually shoot it back to the matching performance of the CO2 concrete compared to the virgin concrete. Not only about the performance is matching here, you can also see the cost. We are using a Sydney local cost of a meter cube per ton. It's about $300 per meter cube in here. But if we because of the cost of the recycled aggregate in general is about half of the price of the virgin aggregate. That's why the recycled concrete is lower in cost. Although we are injecting carbon dioxide and we use labor and we use equipment, the cost is increased a little bit, but roughly we still have about 10% cost reduction compared to the virgin concrete. And we have done some of the real life case study, which is the living lab examples we adopted in the university. The first one that we have done is a biosecurity platform, which is roughly about 40 centimeters by 50 centimeters. We done probably about 4 years ago now. And the right-hand side is a little bit more of a bigger scale, which is roughly about 3 meters by 3 meters slabs. That because of the size of this particular product, that is the reason that we developed the commercial chamber as well. And you can see what is the purpose of, because we have in the Hawkesbury in our farm, the bulls and the animals are actually drinking the water from the cow drinking station. But the thing is, they make a mess. They drink water. They just make the mess. And they say that maybe put a slabs underneath the cow drinking station. They'll be able to just stand on it and then they can drink in it. And it's also providing a weight test for them as well, because each of the bulls is about 1 ton of weight, and you can put roughly about 6 bulls there maximum. That means they can just stand there and then drink the water, and it's also a weight test for us. And that's what we have done for this particular 2 products in the last, I think 3 years ago now, roughly. What is our next step? We actually just joined the HOSIM acceleration program. I don't know whether you have heard about HOSIM acceleration program. HOSIM, you definitely heard of that. This is a season 3 program for this particular year. This particular year, they have over 400 applications, and each of the country that they actually looking into tackling their own issues, and we are honored enough to be able to select it as the winning applications to tackle Australian challenge. What this particular acceleration program is, they're a 6-month acceleration program. They have 4 major industry partners joining this program, obviously including HOSIM as the lead, but Mott MacDonald, Sika, and also Boyos. They are all involved into the discussion. What we're doing in the coming 6 months, this is a 6-month program from June to December. You can see that we're roughly developing we roughly divide into 2 main perspectives. First 3 months, we're targeting in the business model, and the second 3 months is looking into another large scale of the pilot study. What we're looking into the business model development, as you can tell, Although we are running into different of the technology background and also the management background, but I'm not a business person. I don't really know what business model look like. And the good thing is the particular hosting program, they say that it is really important. Let us to see what are our business models, and then we can develop further, which is great, but obviously pushing our team into the boundaries because we don't have any business background. And I go back to the business school and to see some support to develop their business model, which is easy for them. It's just tough for us, but it's easy for them. And each of the partners, they also go back to their company to find their business guru, to come back to see how is it work. And we have done the first major workshop in the early June, but we also have a weekly catch up from them. And we actually have quite an interesting scenery. The products that we are looking on and also the progress that we're looking on is quite different from what we are thinking as well. And I think that will be able to push us into different boundaries. And we are also looking into a very detailed communication plan. A company communication managers is communicating with me to see how can we really promote, looking into the medias, and how can we really further enhance this particular potential contribution as well. This will be done for the first 3 months, mainly for the business model. Once we know the business model of what we should targeting on, we will be looking into another kind of a CO2 concrete pilots. That means we target on what the business want, and then we will try to tailor-made with a pilot. And about July, end of July, we will know roughly about what our business model look like, and we'll be able to start manufacturing our CO2 aggregate in August, and then we'll look into the site selection with one of our partners company. And we are targeting at the moment is looking into 10 meters by 10 meters slabs to producing outside university. We are thinking roughly in the Parramatta sessions or roughly about the areas. But looking at 10 meters by 10 meters slab, which is that mean 100 meters square. 100 meters square, I need 100 tons of aggregate. Thinking about already scale of that, but we'll go through that. And then we'll go ongoing with the monitoring of them from October to December. For the end of this particular program in mid-December, each of the 9 selected team of the 9 countries for this particular program will also go to France to pitch to the partners as well. And I'm looking forward to it. And that is just a quick snapshot. Thank you. Okay, going to the chair session. Any questions? Yeah. 1, 2.
Okay, thank you for the presentation. One question regarding your business model. Quite often the high global warming potential of the concrete product is the challenge of green building. And if I understood correctly, you could reduce that a bit, but not very significantly. Regarding your business model, how do the customers feel about 10% reduction in CO2? Is that already enough on the market at present stage, or are they expecting a higher reduction of CO2 or global warming potential of your product?
Mm-hmm. That is actually exactly what we're looking at as well, because the value proposition of this particular product is to turn waste, not classify as waste. It's not looking into carbon emission as a first instant, but somehow this particular product is to injecting carbon dioxide. I think the attention changed a little bit because of that. But remember, we just want to turn waste, not classify as waste. That's why you can see my focus is the matching performance. And talking about business model is very interesting because with the conversation with the business partners, we're looking into whether we should target the higher use of carbonated aggregates, or we just want to ensure that everyone is using the carbonated aggregate instead. Or so we're looking into more carbon go inside the aggregate. There's a lot of perspective that we can look into. Actually, this afternoon, we'll be meeting together again to identify the products that we want to develop, which is exactly what you're talking about. What products we should be looking at. And also, and then from that perspective, we'll be looking into our potential customer and then the cost and the risk and all the finance perspective as well. We may not be go as far as you can imagine, but we are going through those processes. But it's interesting to change my perspective of looking into the products component as well. Yeah, thank you very much. I think there's a question.
I was wondering about the process of CO2 aggregate. How long does it take to carbonate it?
Mm-hmm. You're asking me a secret.
Really?
Yes. That's the trade secrets.
It's the most curious things about it, because for concrete it takes a lot of time.
Yep.
And I was really curious, but I hope someday you
I
can.
can tell you something. Well, I can tell you this particular product is under patent. That's why it's actually innovative, as you can imagine, and also with a sufficient confidential details within that. What I can tell you is nitrogen is highlighting this is not new, which is available in the nitrogen. The carbonated aggregate, the injecting carbon dioxide into recycled aggregate is not new, but the nitrogen is talking about carbonate for months. Which is, I think, is really impractical to me, because it's impossible. You're thinking about what you want to mix next time, and then you have to think of months ahead to carbonate it, which is not sensible. And what I can tell you is I carbonated. Yep. Okay. That's all I can say. Yeah, and the rest is the secrets. Yeah. If there's no more questions, I think we can close today's sessions. Thanks very much for all the presenters. Yeah, thanks very much for all the presenters. I think the next session we need to go back to the building 16 for the keynote speakers. Yeah, thanks very much and see you guys soon.